Hi everybody. I'm Keith Donadio. I'm an ESE and embedded specialist engineer at I'm embedded solutions engineer at Microchip Technology. I've been with Microchip for almost 15 years, and I developed this course for people that have to do Bluetooth work and have to put together proof of concept apps for Android that aren't particularly programmers. So Java is typically what's always used, and MIT App Inventor is a great alternative.
And we start with the first block.
In this section, I will go over some important considerations for a BLE project. The first consideration is what your BLE hardware looks like. A simple block diagram of your design that shows all of the inputs and outputs is a good place to start. From there, you can determine what types of signals you'll be working with. Perhaps make a list of these signals and whether they are analog or digital. The next consideration is how you want to represent this data now that you have defined it clearly. Is the data best represented with numbers, strings, or perhaps even a simple parsed data protocol? BLE has some realistic expectations that must also be thought of in advance. Latency is one of these. No matter how fast you can sample or gather your data and hardware, there will be some latency in moving this data across the BLE connection. The BLE protocol has more information in its packet than just the data you are sending. Also, there is no guarantee that every byte sent will be received in one single packet. If the data you're sending is considered to be real-time data, then you must also realize how this latency might affect that data. Consider sampling an ADC input every 6 microseconds. There's no way BLE will support sending this data in real time. If you take those samples and buffer them, perhaps even average them, and then send this data every 5 milliseconds, this will certainly meet BLE standards. If you need to stream data fast, for example with audio, there are specific Bluetooth and BLE devices for this purpose. The RN4870 module uses a UART interface to the host microcontroller with the default baud rate set at 115 kilobaud. This does not mean that you can realistically send data at this rate continuously, though. It's important to understand all of these limitations before committing to a BLE project. Please continue to Section 2, AVR-BLE Board Overview. Thank you.
I see. So, I mean, that first section where we define the project requirements, I mean, we just want everybody to understand that RN4870 module has an ASCII interface. So when you connect it to a UART on your host processor, all the data that's going to and from the microcontroller and the module is in ASCII format. So that's why it's important to understand how you're going to format your data. And in all practical purposes, sprintf and a buffer is your best friend here. And then, of course, the other thing to realize is that Bluetooth LE is low energy, low power, and because of that, it doesn't give you the ability to transfer huge amounts of data at a very fast, real-time type of an environment. So if you've got huge amounts of data, BLE is not really what you're looking for. You have to get into the audio spectrum for that.
Just to let you know, this is the board we were talking about. Here we have this RN, what's it again? 49 something.
It's an RN4870.
4870 module. So this is, the course is done with, it's difficult to keep it in front of the camera, this Microchip BLE board. And yeah, you have one too, I hope.
Yeah, I've got one here. Let's see if I can do any better. Those cameras really don't do a good job trying to focus on that. No. But you can see the module. This one's actually, there's 2 modules in this family. The 4870 has more I/O and more peripherals available. There's another one, the 4871, which is the baby brother, which is about half the size of this module. So if size is of an issue, the 4871 might be a better choice.
Okay. So we'll move on to the next block, then we will show what is on this board.
This is what the AVR-BLE board looks like. It is broken up into 3 sections. One for power, one for debugging, and another that includes the microcontroller and the BLE module. In the power section, you can see that the board receives power from the USB connector on the left. There is an option for a connector for a battery, which can also be charged from the USB connection. Below this is the PKOB, or PickKit Onboard Programmer Debugger, along with status LED. To the right, there is the ATECC 608A crypto chip for authentication and security use, a BMA 253 accelerometer chip, and the MCP 9844 temperature sensor. Next is the microcontroller, an ATmega 3208, along with an SST25PF040 serial flash device. The RN4870BLE module is next, along with 3 status LEDs and a push-button switch. The development tools for the class consist of the AVR-BLE board, MIT App Inventor, and an Android device for running our accelerometer app. Before we can use the AVR-BLE board in our app, we have to update the firmware. And to do that, if you look in the resource folder, you will see there are 2 directories. One is for hex file and the other is for the MPLAB X project. If you open up the hex file, you'll see that there is a file called AVR-BLE demo.hex. And when you plug in the AVR-BLE board with the micro USB connector, it will enumerate as a Curiosity virtual flash drive. Here you can see it's mapped as drive D, and you can see there are some files here. So to reprogram the board, it's made real easy by just dragging and dropping the hex file and cycling power. The bootloader will automatically grab the hex file and reprogram the board. So we can just grab the AVR-BLE demo hex file and simply drag it over. It will copy over, and you'll see that it's here. And now all we have to do is cycle power on the board. You'll see the board has disappeared now. And when I cycle power, the board will reprogram. And now we're running the new firmware that will talk to the MIT Android app that we developed, sending over all the ASCII information. Please continue to Section 3, MIT App Inventor Overview.
So just to cover over that AVR-BLE board overview, I mean, you can tell that board has a lot of features, many that we're not using. It's USB powered. It has a battery charger for a LiPo battery. It's got serial flash. We're basically just using the micro, temp sensor, accelerometer, and then the BLE module itself. So many of you might be asking, well, why did we have to reprogram the board with a special hex file, right? So one of the things you'll learn about MIT App Inventor, if you play with it a little bit, is that it's not really difficult, but it's not as powerful a language, being a block-based programming language, to manipulate math and to do calculations. And so the original board was actually sending the raw accelerometer data over, and then the Java Android app was doing all the calculations to show you the meaningful data. I've done that in the source code and the firmware on the microcontroller, and what I'm sending over is the actual accelerometer data that's readable as ASCII text. And so that's the reason why, and you can see that in the source code as well.
In this module, we will create an Android app using MIT App Inventor, which will get you more familiar with using the tool. This is the main screen for MIT App Inventor. At the top left, you can see a button used to start a new project. Let's click it and start our Hello World app now. You can see that you're prompted for a project name. Let's enter Hello World, and then click OK. You can see the project was created here in your Projects folder, and then it opens up to allow you to edit the project. When the project opens, you'll be in the designer mode, and you'll see the app viewer screen. This is what your app will look like on your Android device. Now let's set the screen to have horizontal alignment that is centered. This way, anything we add will automatically be centered on the screen. We can set the app's name here in the screen properties to Hello World. It is also a good idea to enable the screen to be scrollable. This way, if the screen content you create doesn't fit your Android device, you'll be able to scroll to see all of the screen. Here you can also change the title of the screen to Hello World. This way, when you view the screen, you can see that its title is now Hello World. Now from the layout palette, let's select a horizontal arrangement and drag it over. We can set the height to 10%. And then we'll set the width to fill parent, which will fill the screen. This allows us a little bit of separation before we add our label. From the palette for user interface, let's select a label and drag it over to the screen. We will enable the bold font, change the font size to 18. We'll set the text to status. And then we'll set the text alignment to center. Next, we'll go over to the palette for user interface, click a button and drag it over to the screen. Next, we'll enable the font to be bold, change the font size to 18, and then we'll change the text of the label to update. You can see the text alignment is still set to center. Now we'll go to the components and we'll see that we added a label. Let's rename it to LBL status, something a little bit more meaningful. And then click OK. Next, we'll do the same for the button. We'll rename the button BTN and update, just so it has a little bit more meaning when we get to the programming side. So this completes the screen layout for our app. We have a label called status and a button called update. Now we'll go click on the blocks button in the top right, which will bring us to the programming screen. From here, you can see over on the far left all the built-in blocks that are there. You can also see our label for status and our button for update. So when you click on the button update, you will see all the blocks that are directly related to that button. We'll want to drag over the when button update click onto the screen. Every time you click the update button, whatever's in this block will actually run. We'll want to change the status label. So we will look here and get the set label status text to and drag it over and put it within the update click function. You can see there's a red X there, which means there's a problem. There's an error. The error is that we don't have any text assigned to this yet. So we'll go up to the left where the built-in blocks are, and we'll grab a blank text block and drag it over and plug it in. And now you can see the red X has gone. If we click on that text block, we can add the text that we want to show up when we click the button. So let's just click and type in "Hello World!" exclamation mark. Now, to make it a little more interesting, let's indicate something changes on our status by changing the set label status text color. We'll grab that function over and drop it in. You can see that there's still a red X there, which means it's looking for something. It's looking for the color. So when we click on the color block and drag it over, the red X is gone. This completes all of our programming for this app. You can see in the bottom left there are no warnings and no errors. So from here, we're ready to build the project and generate an APK. So click on Build APK for QR code. The app will now be built and generate an APK file. When this is complete, there'll be a QR code displayed on the screen. You can scan this QR code with your Android device, and it will install the APK file on your phone. Here is a screenshot of my Android phone. I'm using the Android utility to scan the QR code. By touching the QR code, they turn on the camera, and I simply hold it up to the screen, scan the QR code, and you can see that it goes out to the URL and asks if it's okay to download this file, if it's okay to open it and install it. And once it's installed, it'll ask if you want to open. So click on Open, and our app is running on the phone. Now if I simply touch the update, Hello World appears in red. And that completes our Hello World demonstration.
Okay, so I did this. What was not shown in this video, I think, was you have to install on your smartphone first this MIT helper app that helps you scan the QR codes. What I found when doing this was that the MIT App Inventor server can be slow, so it can take quite a while before you get the QR code actually, which is one of the reasons why you should not try to follow this course in real time now, but do this later when you have a good internet connection.
Yeah.
You have some
yeah, I mean, this is just a really simple demonstration of how easy it is to build an app using MIT App Inventor, right? And it doesn't necessarily have to be for Bluetooth Low Energy, right? I mean, you can do any type of app with this that you'd like. I personally made one to pick out my lottery tickets, right? But, and Clemens is correct, since MIT App Inventor is a cloud-based tool, it can be very slow depending on the demand, right? So we don't know how many people are accessing the tool all at once and how busy their servers are, but it can be quite slow. But it does give you the option to generate the APK, save it to your computer, and then you can transfer it with a USB cable and install it directly that way as well.
Here, by the way, on the left bottom corner, you can see
In
my
this
certificate.
module, we will learn how to scan, list, and make a BLE connection. So the very next thing we need to do is, once a device is found, when it scans, the Bluetooth LE1 extension starts scanning for Bluetooth devices, it will create a list of devices, and that is in fact called device list. And what we're going to do is, once it finds those devices, we want to list them in our list picker. So there's a couple steps we need to do that. The first thing we need to do is go back to the list picker, list pick connect. Well, actually, we need to get to Bluetooth, and we need to get to the device found. So this is the next control mechanism, right? So once we started scanning, once we find a device, we need to stick it in a list and populate that list pick connect so that we can choose which device we want to connect to. We have the Bluetooth device found, then we'll go back to the list pick connect, and we will grab the list pick connect elements from string. And what this will do is it will pull the elements out of that list and populate them as strings into the list picker so that we can look at those and view those. And you can see it's looking for something to be connected. And so we go back to Bluetooth, and we'll scroll down into the green blocks here, and we look for the Bluetooth LE1 device list. That will be populated with everything that we found in the scan. And so that's it for that particular block. The next thing we have to handle is, after we pick a device from that list picker, so this is going to work like most Bluetooth things you use on your Android. You'll hit a scan button or say, I want to connect to Bluetooth, and it'll show you a list of devices. And then you'll select which device you want to connect to. And then something has to happen after that, after you pick that device. Now we're going to go to the list pick connect, and we're going to go up to the top to an action block here, and we're going to say after picking. So we'll have our list populated. After picking, we want to set our BLE address variable. So if we go back up to variables, and we can just say set to, and we can click here for the name, the BLE address, or the BLE address is what we want to change. And then we can get that address directly from the Bluetooth extension. So if we go back over to the blocks here and we click on Bluetooth, and we go down to the purple functions down here, we'll look for found device address, and we'll plug that into there. And then the only thing we need is an index into it's going to return the address, but we need to know the index of the device list, or the selection index actually. So we're going to click on LP Connect, grab the LP Connect selection index, and we're going to connect that there. So whatever we select on our list, the Bluetooth LE extension is going to give us the address of that device and assign it to BLE address. And now we're going to have to take care of a lot of our buttons and turning them, enabling them, and disabling them, and changing background colors. So the first one we're going to manipulate is the LP Connect, and we're going to disable it. So LP Connect So we'll set LP Connect enabled. We'll go ahead and grab the next one too, the button disconnect. We'll just grab the 3 that we have to manipulate first, and then the button direct. So these are the 3 buttons, and we have to control the states of these buttons. So these are going to be true or false. So we can either go over here to the built-in blocks, and we can grab a logic block and bring it over. The only one that's going to be true is the disconnect, because at this point you will have already picked what you want to connect to. And so the next step would be a disconnect. And since we don't want to enable connect or disconnect direct, we'll make those false. So we can just click on here and duplicate, and then make another duplicate. And then we can plug these in to these other buttons here. And we'll set LP connect and direct to false. So we will have already connected or chosen a device to connect to. And the only thing we want enabled is the disconnect feature. So that takes care of the logic for all of those. Next, we have to handle all of the background, the text colors, right? We want to be able to change the text color. So right here, you can see here's a button disconnect text color. We can actually duplicate this and use it down here. So we'll go ahead and grab that, the button disconnect text color. It's not going to be this mid-gray though, it's going to be black. So we can actually duplicate this black as well. So that takes care of our button disconnect. Next, we need the list pick connect, and he's right here. So we can duplicate him and drag him down. He's not going to be black though, he's going to be gray. And then the last one that we need to deal with is the direct. And we want him to be the same gray color. So we can duplicate that. So now we have these all set up here. We'll put them in order since list pick is next is disconnect and then button direct. So this just takes care of the logic of enabling the buttons on the screen and changing the color of the text. So those are all done now. The last step of this is we actually need to make the Bluetooth connection now, right? So we've chosen what we want to connect to, but we haven't told it that we want to connect yet. So we go back over to the blocks and we click on Bluetooth LE1. You will see a connect with index, and we'll grab him and connect him. And then the index that we want is the same as the index that we used right here. So we'll just duplicate that and drag that down. So that takes care of that. Basically, we told the Bluetooth extension to connect to the device that we selected on the pick event, right? So it gave us a list of devices on the device list. It showed them in a string, and then we touched the screen and said we want to connect to the AVR-BLE board. And then we displayed the address of that board. And then we told Bluetooth extension, let's go ahead and connect to it. So this is going to form the connection. In the next module, we will learn how to make a direct BLE connection using the device's MAC address.
Okay, so we saw that actually to make an app, it's about 80% of user interface, and 20% of real code.
Yeah, it takes a lot of work, unfortunately, to use a block-based programming language, but it is very easy to understand. And while we're doing a scan list connect feature here, which is very typical in Android and iOS for that matter, it's going to show every Bluetooth device that's within radio range. There are other methods I discussed in the video. There's a direct method where you can actually, if you know the MAC address of the device you want to connect to, you can do a direct connection. And then there's also, in the latest BLE extension, there's a way you can use the service UUID so that when you do that scan list and connect, it'll only show devices that pertain to you, right? Because you would have a unique service UUID for your Bluetooth devices.
Okay, so let's continue with the next block then.
In this module, we will learn how to add a graphical display for the accelerometer data. In the last module, we left off where we added LED control and showed the temperature information going back to the screen. In this module, we're going to clean up that design a little bit. You can see here over on the far left that I've cleaned up the look of the screen design for our Android app. you can see that the data LED, which was what we were controlling before, now has a switch that enables it to be turned on and off. And we can also control the red error LED as well. We've also added an indicator here to show whether the switch on the AVR-BLE board is being pressed or if it's released. And then, of course, the temperature, which is what we had before, but I've added also the temperature in degrees Fahrenheit. And then below that, I've added a graphical method to show the accelerometer readings. Now, here what I've done is I've used the horizontal arrangement, which we have used in the past. I used a slider control, which you can grab over here from the palette. And then I've added a label over here on the far right, so we'll have a numeric indication as well as a graphical representation of that information. Going over here to the right-hand side of this, we're going to go back into the strings received routine that we touched on earlier. You can see it looks and feels very much the same as it did before. I've got the BLE transmit routine up here. Now, all these blocks in purple, you can think of them like a C function, really. We call them procedures in MIT App Inventor, but for all practical purposes, you can relate them to function calls. So what I've done here is we go through when we receive data, and we remove that open bracket and the open quotations and the ending quotation and the ending bracket. So I've kind of described that in the previous module. And so what we have here in RX data is the actual real data received from the Bluetooth module. And then what we're going to do is I've got a bunch of nested if-then events in here. And so the very first one, we say if the received data has L, then that means it's a control information for the LED. And so then we call the function getLED. And then similarly, if the received data contains P, that's for push button switch, and then we call getSwitch. And then if the received data contains T, then it's for temperature, and we call getTemperature. And then here, if the received data has X in it, then we know it's for the accelerometer X-axis. And similarly, if it has Y, we know it's for the getAccelerometer Y-axis. And the text box, I haven't done anything different there. In fact, when you feel comfortable, you can remove that. It just shows the data coming over in real time from the Bluetooth module. And then again, the button clear text box is still here to clear that text box. So we haven't really changed much other than to create functions here and added more functionality. Going over to the right-hand side of these blocks, one of the first things we handle is switch data. Now, switch data is this switch over here for the data LED. And so if we were to slide that over, it would create an event, and this when switch data changed would fire. We would see is the switch data on equals true, then we're going to tell it to send the packet bracket LG1 bracket carriage return. And so that will tell us to turn on the green LED. 1 means on. And then we'll transmit that. And similarly, if it's not true, that means the switch has been put into the off position. And so we'll send the LG0 to tell it to shut off that LED. The exact same thing for the error switch, right? So here it is when switch error changes, which is this switch over here. That's going to control the red LED on the AVR-BLE board. Then we're going to send over the LED red on command or the LED red off command. So those two are very similar in how they function and how they work. To get the accelerometer data, we call it, when we see the X coming in, we call the get accelerometer X. And what happens here is we find where that starting point of the X is in the packet, and we tell it to go index one past that and then return the data. And all we do then is we display that data in the label, which is over here on the far right of the screen. And then we also tell it to update the slider X control, the thumb position, with that number as well. It's hard to see here, but this slider has a thumb control position, and I've set the scale from 0 to 100%, so that thing will move from 0 to 100, depending on what the value it receives here. And now that you understand how that X function works, the Y and the Z work exactly the same. The only difference here is that we update different global variables for the Y data and the Z data versus the X data that was here. And again, we work on the different labels, a label for Y, a label for Z, which are also located here and here on the display. That should be pretty easy to understand, I think. And then there's just a couple more things that we do over here. When we get the temperature, again, we see the T, we find where that T is in the data packet. In other words, what index do we see that T in? And then we tell it to go one step beyond the T and return the data that we're looking for. And we simply join that with the degrees C and save it in a variable called global temp C. So whenever we update anything with the temperature for Celsius, we just set the temp C to the label and it will update it. And then a simple conversion here, all we're doing is we're taking the temp data, which is for all practical purposes the temperature in degrees C. We multiply that times 1.8 and then add 32 to that number. And that will convert degrees Celsius into degrees Fahrenheit. And then we will add the degrees F and we will store that in a variable called temp F. And then we simply update the labels for temp C and temp F with those numbers. So over here, you can see there is a label for temperatures in degrees C and temperature in degrees F. And so those two devices right there will update those so we can see the temperature easily. And then the other thing we do, we handle the get LED. So again, we come into this when we see the L in the packet, we call get LED. And we say if in that packet of information we see G0, then that means the LED is off. And so we simply set that switch data to off. So what happens here is before we were controlling the LED from the app, here we are actually controlling the app from the BLE board. So the BLE board is sending us the status of what the LEDs are, and we're setting the switches to show the status. Now this can be a little tricky because we update it once per second, and if you flip one of these switches at just the right time, there's going to be a conflict. I didn't really put any extra effort into trying to fix that. I thought it was just valuable to show that we could receive the information and make these kind of show the current status. So if you were to leave one of the LEDs on and disconnect and then reconnect or shut down the app and connect again, you will see that the LED will show that it's on, and it will do so in this get LED routine. So here we're checking to see if the LED packet says the green LED is off, we turn the switch off. And if it says the green LED is on, we turn the switch on to true. And so SW data is the data LED and the green LED. And then we check here to see about the red LED, the error LED. If it's R0 that we receive in the received data packet, then that means the LED is off and we set the switch error to false. And if it says R1, then we know the red LED is on and we set the switch to true. So this controls the error LED right here on the app screen. Now the only thing left to cover here is there's a switch on the AVR-BLE board, and we can push that switch and have that information sent to our app as well. And what happens is when you push that switch, the receive packet will contain the letter P for push button switch. And then we will call this get switch routine. And we will say that if the global receive packet says P1, then that means the switch is being pressed. I'm using positive logic here. So then what we do is we change the switch pressed button, which is right here. We change that background color to bright green. And we make sure that the released push button is set to light gray. So what'll happen is it sees P1, it says, oh, someone's pushing the button. Let's turn on the button background to green to show that the button's being pressed. And now if it's not equal to P1, we already know that we saw P, but if it's not equal to P1, then we can assume it's P0, which means the switch is not being pressed. And so what we do here is we change the background color again to light gray and to red. And that's it. It's very straightforward. There are some more global variables that I've included up here at the very top. I believe length is being used here to calculate the length of the received packet. X-axis, Y-axis, and Z-axis are pretty self-explanatory. And then that's the raw data. And so length and start are used to determine the length and position of where the data packet lies. And then X data, Y data, and Z data all correlate to the actual data that we want to display. And then we have temp C for temperature in degrees C, and temp F for temperatures in Fahrenheit, and temp data just used to calculate those numbers as well. That kind of wraps it up here for the very last portion of this chapter. I will, of course, once you've come here, you also go up to the build and tell it to build the QR code, and then you can scan that QR code and install it onto your Android app. And so what I'll show in the next segment here is I will show you the app and the AVR-BLE board working, interacting together.
Okay, so you may have noticed that we started very simple and quickly became very complicated. That's because we skipped a few steps. If you want to see the intermediate steps, you should go over to the Microchip University course, of course. Keith, do you have anything to add to this blog?
Well, just a couple of things. I mean, there's a lot of information packed into this this app, right? And you can clearly tell to make a screen look good on Android takes a lot of work. Like Clemens had alluded to a little while ago, it's about 80% making screen look nice, right? And so forth. So it's a lot of work to get something to look nice, but you can definitely make things look nice. And there's many different ways to show data, right? You can use a label, a slider. There's so many different ways. And MIT App Inventor has a large following of third-party people that create special plugins or extensions that allow you to do things like strip charting and stuff like that as well. So a lot of capability, but there are some trade-offs between using a block-based programming language versus Java.
Yeah, that brings me to a question. Once you have created your application in MIT App Inventor, is it possible to convert it to Java and then continue in Java?
Well, what'll happen when you create the MIT App Inventor project, it'll save it as, I believe it's an AIX or AIA is the extension of the project. And if you open that up, it's basically a zip file. And if you unzip it, you will actually see the Java code in there. So I'm not a Java guy, but technically you should be able to grab that code from there and get it into Android Studio in Java. You can also create your own extensions to use an MIT App Inventor if you wanted to do something that wasn't really available in MIT App Inventor and you were handy with Java. There is a lot of information out on the internet to show you how to create an extension where you can just load it into MIT App Inventor and go. Again, Java is a little more difficult for me, but it is possible to do that sort of thing.
Well, personally, I think all the calculation stuff would be easier to do in Java, and all the
Yes.
user interface in block.
Yes, and then to make things tricky, MIT App Inventor, I don't know if anybody really saw when we converted the temperature C to temperature Fahrenheit, we're adding and multiplying numbers, but it's actually a text representation that we get. So it's kind of strange that you can do math, but it comes out as text.
Okay. Well, the last video we have is the app that we just created, so we can see how it works. So let's have a quick look.
In this module, we'll demonstrate the Android app that we've developed using MIT App Inventor and how it interacts with the AVR-BLE board. So this is our Android app that we've developed so far. You can see that I did clean up the screen area a little bit. I created an area over here for the LED status. You can see there's a data LED switch here for the green LED. And over here there's an error LED switch for the red LED. And then over here to the right is switch status, which will show whether you push the push button switch on the AVR-BLE board. It will show whether it's pressed or released. And then down here in the middle, I have a section for the temperature display. On the left, I have it in degrees C, and on the right, it's in degrees F. And then down here in the bottom, I have an accelerometer data area where I've used 3 slider controls to demonstrate in a graphical method the accelerometer data for the X, Y, and Z axis. And over here on the right, there are labels that will actually give you the numeric value of the accelerometer data. And down here, I left the text box there so that we could still see the raw streaming data coming from the BLE module on the AVR-BLE board. And of course, the clear text box to be able to clear that. So to demonstrate the app, we're going to go ahead and do a direct connection. You can see that the blue LED came on. The green bar up here shows we have an active BLE connection. You can see data is being streamed down here on the bottom. We can hit that clear box. You can see every 1 second interval we'll get data coming across. We can control the LED, green LED and the red LED. If I push the switch on the AVR-BLE board, you can see that it goes green for pressed and red for released. And of course you can see the accelerometer data down here in these slider bar controls. To demonstrate the accelerometer, I'm going to tilt the board to the right and we should see the x-axis increasing. You can see it's gone up to 78 and 80. And if I tilt the board to the right, you'll see it decreasing down to 31, 29, 27. So now if I tilt the board forward, we should see the y-axis increasing. And if I tilt it towards me and down, you'll see it decreasing. And so that demonstrates our Android app. I hope you enjoyed the module, and I hope you enjoy working with MIT App Inventor.
Okay, that's it. That's the end of the presentations. I will paste the link on this slide. You can see the link to the Microchip University course. I will also paste it again in the chat box. There you go. You can also see that I completed this course with success and I have my certificate. So if you do the same, you will get one too. We will now try to answer... oh no, I have one question first before I give the Q&A to you. Are there any, Keith, are there any ways of debugging your app in MIT App Inventor?
There is a little bit of a way to debug. So when you are doing the block-based programming, if you hover over that and right-click, there is a selection for Do It. And what'll happen is if you're connected to App Inventor over the USB cable to your Android phone, you can actually make changes and see them happening in real time on your phone. And you can click that Do It button and it will execute the block that you've chosen to execute. So people have asked, how do these blocks work? Do they work like a main function in a loop? And they're all event driven. So they're all logic and procedural type blocks. And they're pretty self-explanatory. If you click on this button and that event fires, then it's going to execute this piece of code. And so it's not really sequential, but there are some debug methods. And the one I described with the USB cable and the Do It are pretty much the best way. There's not a lot of in-depth. It's not Java, so you're not going to do a single step and break per se. But there are ways to debug it. It's not pretty. But for those of us that get involved, I got involved in this because as an embedded solutions engineer at Microchip, I am in a special function group that supports our wireless products. And most of my customers are Bluetooth data customers, and specifically BLE. And so what'll happen is an engineer will say, I need to implement BLE and hardware. How do I do that? And then almost immediately is, do you have an app that I can use, or can you make me an app? And it's like, well, I'm not an app developer per se, but MIT App Inventor makes it real easy for just about anybody to create a simple proof of concept app to test out their BLE hardware.
Indeed, it is. I tried it. I can confirm this.
Well, Clemens found out, so there are some nuances with MIT App Inventor. So we rely heavily on the BLE extension to give us the BLE connectivity. And so depending on what phone you have, what version firmware operating systems running on the phone, you may encounter some small issues. There is a huge MIT App Inventor following. MIT App Inventor has their own forum. The people there are very responsive to problems like that. I had a problem getting an older extension to work on Android 9. And so that's why I used the latest version of the BLE extension on these exercises, because it would allow most everybody's phones to work. Unfortunately, Clemens found out that he could not get his phone to work at all. One other caveat is when you do a Bluetooth app on your Android, the very first time you install it and run it, it will ask for permission for location. And you have to say yes to this. Bluetooth has many different forms and functions, and out in the real world, there's a lot of beaconing type stuff happening. And so what you could typically think of is, it sounds funny, but if your wife is walking through the mall and she walks by the shoe store, they could very well have a Bluetooth beacon there that says we're having a sale. And if she has their app loaded, it will trigger a notification on her phone and say, hey, we see you're close by, come on in, we have a sale. And so that's just one general, simulation of why the location is required. But if you don't enable locationing, it will not work. So that's just one thing to be sure to know when you install this.
Yeah, for me on my phone to activate location service, I have to actually activate the GPS, so it's a bit but then it does work most of the time. So let's move on to the questions from our Q&A session. We are running a bit late.
All right.
Here we have one. So what kind of certifications does the module have?
So if you go to the Microchip website and you go to the RN4870 web page, there are tabs in the middle of the page, and there's one for documents. And so under the documents, you'll see there's a RN4870 regulatory approval document. And in that document, it will show all of the FCC, IC, red. So it's Canada, China, Europe, India, Japan, Korea, Taiwan, and USA.
Okie dokie. Next question. Certification documents.
So our modules, all of the Microchip Bluetooth modules and Wi-Fi as well, they use what's called a modular certification. So we have gotten the modules certified through the FCC, IC, and all the regulatory agencies. And so if you design it in and don't alter it in any way that can create any RF radiation or noise, you'll be able to get your approvals. I believe, I'm not a regulatory expert here, but I believe even though it has a modular certification, once you get into production, if you're using a contract manufacturer, they can typically certify it for you. It's very easy with the modular certifications. Now for CE and FDA, FDA approvals are medical, right? So I have done designs with customers that have gotten through FDA. Bluetooth has never been a problem in that respect.
Okay. Next question. Yes, we will be sharing the recording of this webinar. It will probably tomorrow be on YouTube. Here we have another question.
Yes. So there is a way. So under MIT App Inventor, in the well, here, let me see if I can get there myself. In the designer mode, so there's two methods in MIT App Inventor. On the top right corner of the screen, there's designer and blocks. And if you're in the designer mode, over on the far left, you have a column called the palette. And in that palette, there's user interface, layout, media, stuff like that. If you go down, there's one called storage. And in storage, there is cloud database, files, tiny database, and tiny web database. And so you can actually use, I've used the TinyDB. It basically looks like a variable in your code, and you can just stuff data in there. And then when you switch screens, you can pull it back out. So you can have a multi-screen app, and that's how you would get the data from one screen to the next.
Okay, I have to unpublish this. Again, to go to the recording, here we have one. Is there something like a while loop?
Yeah, so there is. So again, in MIT App Inventor, on the top right corner, you'd go into the blocks mode, and in the blocks on the far left, under built-in, there is a control blocks. And if you look in those control blocks, there's if then else. There's things for each number from, while. There's a few different ways, right? There's a while test do, so it's kind of like a while do loop, which is the closest thing we're going to get to a while loop in C. But yes, you can do something like that. Certainly can.
But I think maybe the question is also, is there somewhere in the background a while one loop running?
So the main screen is not really like I guess you could think of it like a main function in C, because if you only have one screen, like the app we created, it just has one screen. And so you can consider that the main loop or whatever, right? Everything in that one screen will execute depending on what blocks get fired or what event gets triggered. Like we had the purple blocks that were like C function calls. And what we did was there was a BLE strings received function. And so when BLE sent data over, that strings received function event fired, and everything in that control block was executed. And further, we looked at the strings and we said, well, if there's T for temperature, then go call this function or this procedure, which was a purple block. And it went out and ran everything in the purple block and then came back. So it's very structured. And in some respects, it is sequential, but it's event triggered. So it doesn't work quite like a main loop in C.
Okay. Here we have about designing a screen.
So yeah, if you look at the example project for the accelerometer, you can feel the pain of trying to move things around and get organized on a screen. So in the designer view, under layout, there are horizontal arrangements, there's table arrangements, and there's vertical arrangements. And these are methods to get and position whatever you want on the screen in the way that you want. A table arrangement is basically a grid, right? You've got rows and columns that you can position data. A horizontal arrangement is just a horizontal bar, and you can change the size of that. On the main screen, you can also choose the positioning. In the very beginning, we set that for horizontal positioning to be centered so that everything we put on the screen would be centered. And on the scan and disconnect portion of that, I used a horizontal arrangement and I put spacers in there to kind of position everything. So you can't really position it anywhere like a Visual Basic or Visual C where you can just drag and drop it and it just is anywhere on the screen. It's a little more difficult, but you can get it within reason pretty much anywhere you want on the screen.
Okay. This one we already did.
Is it an accelerometer or a gyro? This particular one on the AVR-BLE board uses a Bosch BMA 253 accelerometer. So it's a solid state, I believe it's a piezoelectric accelerometer with an I2C interface. There's certainly no reason why you couldn't interface to a gyro though.
Okay. Here is one for you.
So it's funny you should say that. So Microchip, as some of you may be aware, we do have a lot of modules, and Wi-Fi modules are one of those. We have the Wink 1500, which is our most popular Wi-Fi module. And it's a simple SPI interface to your host microcontroller. And we actually do have small evaluation boards very similar to the AVR-BLE board. So that is kind of the natural progression to put something together for MIT App Inventor for Wi-Fi. And as you can imagine, of course, you can connect to Wi-Fi as well with MIT App Inventor. So yes, I am thinking about that. I don't know if we'll see it this year, but maybe in 2022.
Yeah, well, looking forward to it. Here is a difficult one. The UUID.
So the UUID, so the service UUID just identifies, let's see, think of it like your birthday, right? So I was born on January 20th of 1964. And yes, I'm really that old. So if I was to advertise my date of birth, 1/20/1964, that would be a unique identifier for me. It would be different than you. And that would be typical of like a service UUID. It identifies a Bluetooth service. The characteristics that lie below that service use different UUIDs as well. So you would typically have a service UUID, and then you'll have characteristic UUIDs underneath that. And so in our app, when you look at the blocks, in the top left corner of MIT App Inventor, I've created variables. So there are variables for service UUID, transmit UUID, receive UUID. And these are all unique to the RN4870 Bluetooth module. Yes, you can use those, but it's much easier to just, so like, yeah, I'm trying to figure out the easiest way so I've written an app that uses, I scan for a service UUID, right? So that I can only see this one customer's devices because they use the same service UUID. So when I scan to list, I only see their products. And then when I connect to them, they all have the same transmit and receive UUID. So as far as the RN4870, if you use the default settings and the built-in transparent UART mode, it's always going to have the same service UUID, the same transmit UUID, and the same receive UUID. So those devices will, if you assign those UUIDs to a variable, it's just simply looking at the variable or writing to that variable. I hope that answers the question.
I hope so too. I'm sure it did. It was very clear. Here we have a good one.
Hey.
Well, thank you. Yes, indeed, we do have a book at Elektor about MIT App Inventor. I will paste a link to it in the chat box. I will do that right now. We even have a bundle, so you can see find link to the book in the chat box. Thank you for reminding me. No, I have to unpublish first. No, that's okay.
What do I do if space on the App Inventor page is full and there's no more space for further blocks? Well, there is on the lower right corner of the block page, there's plus and minus that allow you to zoom in and zoom out. So if you're zoomed in, or if you just go in and you don't do anything, if you click the minus button, it will zoom out, and that should show you, you know, a little bit more room and what have you. And if you just right click in any of the white space in that block-spaced editor window, if you just right click, or left click rather, left click, you can actually drag everything around and get yourself some more room. So you can zoom out or you can move around using the left mouse click. If you get everything filled on that page and you still need more, I think you would have to probably look at maybe creating another screen, which will give you another block-based window to put more. You'd have to split up your app a little bit to allow you more room.
Yeah, I would say if your page is full, then maybe you should move on to Java.
Yes, that too.
So what versions of BLE are supported by MIT App Inventor?
Well, that's a good question. So the BLE extension supports Bluetooth Low Energy, so it'll go all the way back to the very first version, which I think is 4.2, if I'm not mistaken. So it'll support the 4.x, the very first versions of BLE, and then there's also a Bluetooth Classic Bluetooth extension that you can use in MIT App Inventor as well. So if you wanted to make some app that you could select an MP3 file or whatever and stream it, you can do that as well in MIT App Inventor. So I know Microchip is coming out with a Bluetooth 5.2 device here very shortly, and I'm actually talking to one of the guys at MIT App Inventor to see if that's going to be supported in App Inventor as well. But for all practical purposes, the only difference between versions are, well, I shouldn't say only. I mean, there's some security things, data payload, range, stuff like that are most of them. So different versions of BLE are mainly broken up between Classic and Bluetooth Low Energy, really.
Okay. And one last question. I don't know if you know the answer to this one.
Are library functions to access hardware features of the phone? Yes, there are. So here's a really neat thing. And in one Bluetooth app that I wrote, I used the camera. There is a, let me see if I can see it really quickly. Let me see, where is it? It's probably under media. Under media, in the designer screen on the palette under media, there are selections for just what you're asking: camera, image picker, sound player, sound recorder, stuff like that. I used one called barcode scanner, where I could scan the barcode on the actual Bluetooth module, which will give me the MAC address. And then I simply do a direct connection from there. So you can imagine walking up, telling the thing to connect, scan the Bluetooth module's barcode, and it just automatically connects. And those are all free. There's no charges for MIT App Inventor at all.
That's really nice.
Yep.
One last question came in. Well, we'll do it then. So, can you publish your app?
You know, I really don't know the answer to that one, to be honest with you. App Inventor creates an APK file. It will load it on your phone over Wi-Fi, over the USB cable. You can also generate the APK as a local file on your computer. So I don't really know what's involved in publishing to the Play Store, but since you have the APK and you own it, I don't see any reason why you couldn't publish it in the Play Store.
Yeah. I once published an app on the Play Store. It was just a lot of questions and a lot of hassle, but nothing complicated. Just a lot of forms and to be sure that no viruses inside, etc.
Right.
So I think that's no problem.
So okay. I saw one other question, Clemens, and somebody had asked, you know, besides Android, can you generate an iOS app using MIT App Inventor? And so App Inventor right now, as far as I know, is only for Android, but they are working on a version where it will generate an iOS, an iOS app as well. I don't really know where the status of that is because unfortunately I'm not an Apple guy, right? But they are working on it. It may be available today, but just go to the MIT App Inventor website and check it out. It'd probably be underneath their forums. Thanks, everybody. I really appreciate your time, and I hope you have fun with MIT App Inventor.